Hello everyone, welcome back. Today Leetcode question called continuous subarray sum. Basically, it give you an integer array and an integer k, and it asks you to return true if there exists a good subarray, false otherwise. So what is a good subarray? There's two properties. The first one is the length has to be at least 2. The second one is the sum of all elements inside this subarray has to be multiple of k. Okay, so return true if there is a good subarray, false otherwise. So let's look at the example. So from here we can see that 2 plus 4 actually equals to 6. 6 actually is a multiple of 6, right? So this is a good subarray. We can also see that 2 plus 4 plus 6 equals to 12 also is a multiple of 6. So this is actually a good subarray also. So return true. So let's look at the second example. So you can see that 2 plus 6 plus 4 equals to 12 equals to 6 times 2. So it's a multiple of 6. It's a good subarray. So return true. And then the third example, we can't find any good subarray here. So return false. So let's talk about the approach to solve this question. So to solve this question, we need two things. One is running sum. The second one is a map to record the index. The map to record the index. Why we want to record index is because we want to check the length, right? So we can use the index to check whether the length is larger than 1. If it is larger than 1, then means it is a good subarray. Okay. So the running sum, right, is basically we summing up the things, summing up all these things. But we summing up, right, we not simply summing up. We summing up, after that we need to mod. We mod it. Okay. So C23 what's 222647. Okay, so first the running sum is 0, and then 0 plus 23 equals to 23. But then what I said just now, we have to mod it and then record it inside the map. So 23 mod 6 equals to 5. So record the 5 here, and then record the index, which is 0. And then the second one 2. So 5 plus 2 equal to 7, and then mod 6, which is 1. Yeah, 1. So 1, record the index, which is 1. After that 6, and then 6, so it's like mod 6 equals to 1. Okay, the next one 6. So 1 plus 6 equals to 7, and then 7 mod 6 equals to 1. And then we found that 1 actually already inside. Then we just need to check. Then what we do is check whether the current index minus the index recorded in the map is larger than 1. So now it's 2, and then inside here is 1. Actually it's 1, so it's like it's not larger than 1. It's not 2 or 2. It's not at least 2. So this cannot be a good subarray. You can see. Yeah. So the next one, 1 plus 4 equals to 5, and then 5 obviously mod 6 equals to 5 and then we find that 5 actually already inside, and then the index record inside is 0, and then the current index is 3, right? So 3 minus 0 equals to 3. So means that this subarray of length 3 actually is a good subarray. Okay, this is the approach to solve this question. So basically the idea is, if we running sum, we meet some number before, maybe like 3. Then after that we keep summing up, we meet a 3 again, means that this subarray actually is a multiple of k. Okay. Yep. So I hope you understand this concept. So let's look at the code implementation. So yeah, like I mentioned just now, you need an unordered map, and you need a running sum. For this one is to, why we want to do this is for a base case where like you have a 2 and 4. Okay, first you record 2 and then 2 plus 4. Okay, the first iteration you record 2 in the map. The second iteration you record 2 plus 4 equals to 6. 6 mod 6 equals to, okay, this for this guy k equals to 6. 6 mod 6 equals to 0, right? Then 0 is not inside the map if you didn't do this. But if you do this, 0 inside the map, then if you do this, 0 is inside the map, then we can return true, because this is actually a subarray. Okay, so after that we keep summing up the nums, and then we mod it, and then we find whether the sum is inside, whether the current running sum is inside the map. And if inside the map, then we check if the size is larger than 1. If it is, then return true. So this one, after that, we check if the index is inside. If inside, then we don't need to update the index. If not inside, then we update the map with the new running sum and the index. So return false if we can't find any good subarray. I hope you understand my explanation, and I hope I explained clearly, and feel free to leave any comment, any feedback, and any algorithm that you might need me to share with you. Thank you.